Okay, hello everybody. This is question 2 of the kinematics one-dimensional problems. So this one involves a rocket. Suppose the rocket in space moves with a constant acceleration equal to 9.8 meters per second, which is the same as the acceleration due to gravity on Earth. So question A asks, if the rocket starts from rest, how much time will it take for the rocket to reach the speed of 1/10 of the speed of light? Now the speed of light is quite fast. It's 3 times 10 to the power 8 meters per second, which is 300 million meters per second. And 1/10 of that is still quite fast, which is naturally it would be 30 million meters per second. So how far will the rocket travel in this process? So let us begin by drawing a rocket. Goodness, this is alright. And let's just imagine something like that. And we can make our axis as positive, y is positive up, and to the right positive x. I don't think we'll need x in this problem, just y. Okay, and then question A. So question A, we want to get the time it takes. So this thing starts from rest, so its initial velocity is 0, and the final velocity is 1/10 of the speed of light. So the final velocity is 0.1 times c, which is 0.1 times 3 to the power 10, which is just 3 to the power 7. So we can already write this as 10 to the power 7. 3 times 10 to the power 7. So we know what the final velocity of this rocket is going to be, and we know the initial velocity. So we want time. So the formula we use is the final velocity is equal to the initial velocity plus the acceleration within that time frame. If we make time the subject of the formula, we get Vf minus Vi all over A. And we can immediately plug in the values here. So the final velocity is 3 times 10 to the power 7 meters per second, and the initial velocity is just 0, so that does nothing, and we're dividing by 9.8 meters per second. So if you take this value, these values, and put them in a calculator, you get an answer rounded off to 1 decimal place of 3.1 times 10 to the power 6 seconds. So this is effectively 3.1 million. So it will take 3.1 million seconds for this poor rocket to get so fast. So now the next question is, what distance would it travel in this process? Well, it will have probably, we can already guess it's probably going to be quite a large distance. So the formula we use here is the final velocity squared is equal to the initial velocity squared plus twice the acceleration and then the distance. So the distance is, let's say, as it's traveling, it eventually reaches a distance of yf for y final, and then the position from which it started we can just call yi. We can set yi to 0 because we can assume it started from the ground, and we can just make the ground 0. Distances only make sense when you measure one point relative to another, and we normally make the base point 0. So let's do just that, just simplify the algebra a bit. So we've got Vf squared is equal to Vi squared plus 2a y. I won't even write yf, let me just write y. So we want to make y the subject of the formula. We subtract Vi squared on both sides and divide by 2a. We get y is equal to Vf squared minus Vi squared all over 2a, and we can plug in these values. We know that the final velocity was 3 times 10 to the 7 meters per second, and remember this is now squared, minus just 0, and 0 squared is just 0, so we don't care. And then 2 times the acceleration, which is 9.8 meters per second. Let's expand that just for, so 3 squared is 9, and 10 to the 7 squared is 10 to the 14, and then our 14, sorry, and then our unit is meters squared times second to the minus 2. Let me just make it more clear. 2 times 9.8 is 19.6, and it's meters per second. So the seconds to the minus 2 cancel nicely. Meters squared divided by meters, we just get meters to the 1. This guy goes away. And we have to put this in the calculator as well. And we get an answer of, again, rounded to 1 decimal place, 4.6 times 10 to the 13 meters. So this is quite a long distance. And I don't think we have the capabilities yet of reaching such speed, at least not with a rocket. But anyway, thanks. See you with the next problem, probably in another video. Alright, bye bye.